Okay, hello everyone. My name is Anurag Vempati, and today we'll be doing some textbook practice problems for lesson 7-5, numbers 32, 33, and 51. Okay. So, if you're looking in the textbook at number 32, presented with a diagram of the situation. So, a baseball player hits the ball at an angle of 28 degrees with an initial speed of 103 feet per second, and the bat is 4 feet from the ground at the beginning. Assuming the ball is not caught, meaning it's allowed to continue its arc, determine the distance traveled by the ball. So because this is a parametric equation problem, we can use the parametric equations. So one parametric equation is x equals, one is y equals, and the equations are based on initial velocity, some stuff, I probably should have these memorized, but I don't. Wonderful. Oh, here you go. Okay, motion. The parametric equations are VO cosine of theta times t, and y equals negative 1/2 g t squared plus VO sine theta t plus k. So, theta, obviously, is an angle. Initial velocity is just the velocity throughout the problem, VO, and k is the starting height. So, we are asked to determine the distance traveled by the ball horizontally. So, let's draw a little diagram. Now this is up at 4 feet, so this is 4 feet, and it gets hit at an angle of 28 degrees with an initial velocity of 103 feet per second. So determine horizontal distance, x, however far it goes. We need to find that. And to find that, we need initial velocity, the angle, and time. So we have the initial velocity and angle, but we don't have time. What we do have is we have k, the angle, initial velocity, and the gravitational constant, which in this case would be 32 feet per second. Feet per second squared. My bad. Acceleration is a second squared. So, using this equation, we can solve for time, because we know that the maximum horizontal distance traveled, the ball will have gone on arc path and then hit the ground where y equals 0 at some point. So what we can do is we can say y is equal to negative 1/2 gt squared plus VO sine theta t plus k. We can say that 0 is equal to 1/2 32 t squared plus 103 sine 28 times t plus 4. So, using this information, we determined that negative 16 t squared plus 103 t sine of 28 plus 4 is all equal to 0. So, at this point, you just solve for time. And an easy way to do this is to just grab your calculator. You have it here. Take it. Oops. Okay. X squared plus 103 x sine 28 plus 4. I'm in degree mode. Hit enter. Calc. Actually, I should probably adjust my window. I'll just do something like this. Graph it. Wow, I can make my window a lot smaller. Don't use 100 as your window. Okay, there you go. Calc 0. So this side is probably negative, so we'll go up here and we'll find the x-intercept. Left is on the left side, right's on the left side. There. So t is equal to 3.1027957. And the reason I'm not rounding it is because if you round it, you will get not the correct solution for this one, because you need to be completely unrounded. Because if you round it, you're skewing your results and then multiplying it by skewed results and then therefore skewing your x even more. So taking this time that we have right here, also we have the initial velocity as well as the angle, 28 degrees. We can plug it into this equation. So x is equal to 103 cosine 28 times t, which is 3.1027957. Okay, click that. 103 cosine 28. Make sure you're in degree mode. I am. Times 3.1027957. Did I remember to hit record? Okay, good. Thank God. Thought I did. Okay, there you go. Let's go. So, let's figure out that x is equal to 282.18 feet. And that is your answer. That is the horizontal distance the ball traveled if it wasn't caught and it continued on its path all the way. So, the general rationale behind this is we're looking for horizontal distance and we don't know one of the variables in the equation. So to find the variable in this equation, we use this equation because we have all the variables we need for this. So we know that y equals 0 because if it were to travel the whole horizontal distance, that's when it hits the ground. When it hits the ground, it's 0. Because if we keep going, we follow it, this is the maximum distance, and this is also when y is 0. And so we have 0 there. The gravitational constant, okay, so the constant is 32 feet per second squared, or 9.8 meters per second squared. That is a constant. It will always be that. Time is what we're solving for. VO was given to us. The angle was given to us. Time we're solving for. And K is the starting height. So the ball started at 4 feet. And And so using this equation and all the variables that I just explained, we solve for time. And then using this time and the two other variables in here, velocity and angle, we were able to find the horizontal distance the ball traveled. Here's the math behind it, and that's how you do it. Okay. Moving on, let's go to problem number 33. And this one follows the same lines. It's a little bit different. You can use the same parametric equations. So I'm just going to go ahead and write those right now. VO cosine theta times t equals x, and 1/2 gt squared plus VO sine theta t plus k is all equal to y. And we also know our gravitational constants. They are g is equal to 32 feet per second squared, or g is equal to 9.8 meters per second squared. Okay, let's go on to the actual problem now. So Del Mar attempts a 43-yard field goal. So x is equal to 43. He kicks the ball at a 41-degree angle, with an initial speed of 70 feet per second. Initial speed, 70 feet per second. The goalpost is 15 feet high. So this is the goalpost. Goalpost height. Is the kick long enough to make the field goal? Okay, so we'll do a diagram. So we have this field goal here. He is 43 yards away. This is 15 feet tall. 15 feet tall, 43 yards. And this is the football. It's getting kicked at a 70 feet per second at 41 degrees. So, because this is football, actually, never mind. Okay, so you have 2 units that are feet and 1 unit that's yards. So, in order to make everything the same, we can either change everything to feet or change everything to yards. And because it's football, we should probably change everything to yards. So, 15 feet divided by 3 will get us 5 yards. And 70 divided by 3 is not divisible, so it gets us 23.3 repeating yards per second at a 41-degree angle. So, now that we have all our units in place, we have all our information set out, what we do is we need to find at 43 yards, when it gets here, is it above 15 feet or 5 yards? Because if it's above 15 feet, then it will make it into the field goal. So the way we solve this problem is using the first equation, we find time, and then we plug the time in here, and we find out its height. If the height is above 15, it makes it. If the height is below 15, so if y is greater than 15, we're good. If y is less than 15, he misses. So it's kind of a reverse of the other problem, because in the other problem, we used this equation and went here. And in this problem, we're using this equation and going here. So what we're doing is VO cosine theta t equals x. So 70 times the cosine of 41 times t is equal to 43. So t is equal to 43 divided by, my bad, we should not be using 70 because we're supposed to be using yards, because it's 43 yards. Okay, so it's 23.3 repeating times the cosine of 41. Wow. Right? Okay, that's a little blurry. Let me just rewrite it. T is equal to 43 times 23.3. Repeating cosine of 41. Okay, and when we plug this all into our calculator, I cleared my calculator, so I gotta go back into degree mode. 43 divided by 23. Hang on. Just gonna borrow this. 23.3 cosine 41. T is equal to 2.4418096. And then using this time, we plug it into this equation. And because we are going in yards, we need to change feet per second. So 32 divided by 3 gets us 10.66. So G is equal to 10.6 repeating yards per second squared. So in our new equation, y is equal to 1/2 10.6 repeating times t, which is 2.4418096 squared, plus 23.3 repeating sine of 41 and 2.4418096. And we don't have a k value. K is equal to 0 because the ball is starting on the ground, so there's no initial elevation. So you can just stick with this. So we plug all this mumbo jumbo into our calculator. You get negative 1/2 10 point. Yeah, let's go here. We use the 10.6 2.14 squared plus 23.3, in parentheses, sine of 41, all of this times time. So we do all that, and y is equal to 5.57, 5.58. So you might be thinking, oh, well, it's only 5.8 feet. Well, crap, it doesn't make it. Well, you have to remember, this is in yards. So we multiply this value times 3, and we get y is equal to 16.74 feet. And hopefully, if you're at this level of math, you know that 16 is greater than 15. So it does make it. And so the field goal is good, and it clears it by 1.74 feet. And they didn't ask us for how much it clears it by. I kind of just tack it on there because in another problem, they will eventually. That's how you figure it out. You just subtract the two values. Okay, so that is how you do number 33 in the textbook. Oh, I forgot. 32 and 33, both of these are on page, what page number is this? 469. And now, considering I told you guys that, you might also be wondering, why the heck am I not doing the problems on the in the actual worksheet that Mr. Brown gave us? That is because I'm very scared of getting caught, of performing academic dishonesty. So I'm just doing example problems, and then using the concepts you've learned from the problems, hopefully you'll be able to do stuff. But if you can't, then let me know in the comments below, or email me, which you should find on my profile. So, the next problem we're doing, oh my god, what is it again? 51! Yay, if only I was actually able to remember that, not be an idiot. Okay. So, for number 51, it's a problem problem where we have a graph and we have to use the information found on the graph to find the initial speed of the ball, find the time that the ball reaches. Okay, yeah, let me just explain the thing. Okay, so what essentially happened is you got a soccer ball. Someone kicked it, it went flying, and someone hit it with their head. As a collision, and the ball went back. So the graph looks a little something like this in the textbook. Hopefully, if you're listening to the video or something, you can also reference the textbook, because this graph is going to be seriously trash. Okay, so you go up like this, and this is a rough sketch. And then when the second person heads it, goes a little up like that, and back down to the ground. So this is the path of the kick. So this is y, this is x, this is height in, I'm assuming, feet, and this is distance, also in feet. Okay, so that's what the ball looks like. They give us a point on the graph. It is 7.5. But wow, that's dumb. Okay. It is, oh, never mind. It is 5.77. That's on the graph there, and that is when time is equal to 0.4. And up till here is the initial kick, and then this is after it's been headed, this little curve here. Okay, so we have a point, so x is equal to 7, y is equal to 5.77, and theta is equal to 50 degrees. And they give us this information in part A of the problem, because it says the ball is initially kicked at an angle of 50 degrees. Find the initial speed of the ball. So to find the initial speed, we also have a time of 0.4. What we can do is throw it on our parametric equations. X is equal to VO cosine theta t, and y is equal to 1/2 gt squared plus VO sine theta t plus k. Right, and because he kicked the ball, we can just ignore k because k is equal to 0. So those are the full equations, but k is equal to 0. Okay. So using the information we got from this point, t.4, 7, 5, 5, and the angle, what we can do is if x is equal to 7, initial speed is what we're solving for, cosine of the angle, and then we're given a time, 0.4, we could solve for initial velocity. So initial velocity is equal to 7 divided by the cosine of 50 times 0.4. So 7 divided by cosine 50 times 0.4, all of that. Okay, degree mode. So initial velocity is equal to 27.22516697. I really hate rounding just because it's imprecise, technically. It's always imprecise, not even technically, it just is imprecise. Okay. So this is the initial speed of the ball. This is the answer for part A. So part A, the answer is 27.22516697. Now on to part B. Part B, they ask us what time the ball reaches the second player if the second player is 17.5 feet away. So 17.5 feet away, that means this distance here is 17.5. So x, for this part, is equal to 17.5 feet. Our initial velocity from the original problem is from part A. We have this, and theta is equal to 50 degrees. So using this information, we once again use the first parametric equation. x is equal to VO cosine theta t. We can plug in our stuff. 17.5 feet is equal to 27.2251667 times the cosine of 50 times time. And time is what we're solving for because we want to know what time the ball reaches the second player if the second player is 7.5 feet away. So we take 17.5 divided by 22.2251667 times the cosine of 50 is equal to time. So 17 divided by this big number here, cosine 50 is, so the ball reaches the second player at the time 9.74285714 seconds. And I think we can just reduce that to, because this is the actual answer, we can round 0.971 seconds. Okay? Finally, the last part of this problem, part C. So, if the second player heads the ball at an angle of 75 degrees, at an initial speed of 8 feet per second, and at a height, so K is equal to 4.75 feet, a height of 4.75 feet, how long does the ball stay in the air from the time it is first kicked until it lands? So we're looking for when y equals 0, and we're solving for time. So using this, all this information, it fits our second parametric equation, the y equals. So y is equal to -1/2 g t squared plus VL sine theta t plus k. So filling in our information, 0 is equal to -1/2, and because it's feet, our constant is 32 time squared plus initial velocity 8 sine of 75 times t, we don't know, we're solving for it, plus 4.75. And from here we just use our calculator again. Y is equal to -1/2 times 32 times x squared plus 8 sine 75 x plus 4.75. Okay. Oh, sorry. There we go. There. Window. We'll just do 50 now because 100 was a bit much last time. Okay, let's graph it. Wonderful. It's even worse than last time. Okay. Come on. There you go. Okay. I'm just going to work with it. Don't use the window like a terrible window like I did. Okay. So, we're looking for the x value where that is because we know we're still above the x-axis. I can hit enter here. It's barely above it. Then I can use this left, right, basic calculator stuff. So at that point, time is equal to 0.8374581. So the time the ball was in the air from when it was initially hit to when y equals 0 is 0.837 seconds. And that is the answer to part C. And that is how you do number 51 in the textbook on page 470. All right. That's the end of the video. If you have any questions or would like me to work another problem that is not on the worksheet, feel free to comment on the video or email and or text me if you have my number. And that's it. All right. See you guys next time. Anyone else has any math related questions?